This is a problem that involves distance, rate, and time.
Yeah.
What's the general formula that relates those three things together?
Distance equals rate times time?
Uh-huh. Dirt.
Yeah.
That's what I always remember. In other words,
Okay.
I don't remember that rate is distance divided by time, even though it is. I only want to remember one thing in my brain. I can do all of the algebraic manipulations of it that I need to. But the only one I want to remember so that I never get it wrong is dirt.
Okay.
Okay? So, this is a relatively difficult problem because it's going to have two variables. Okay? How far was it to the park? Well, in other words, all word problems become a lot easier if you define your variables first.
Yep.
Okay? Then they actually become very easy. In fact, let's start out with an easy one. Let's start out with 3 instead of 1. We'll get back to 1 after we do 3.
Okay.
But I prefer going easy, medium, and hard rather than starting right off with a hard one.
Okay.
Okay, number 3, the way you define your variables is you look at the last sentence. What are the numbers? Well, X is going to be the first number they're talking about. Y is going to be the second number. Okay? Now, the sum of two numbers is 110. How can I write that as an equation?
X plus Y equals 110.
And their difference is 50. How can I write that?
Y minus 50 equals, wait, no.
Well, we don't know which one is bigger, so I can say X minus Y equals 50.
Okay.
Or Y minus X. It's not going to matter. We're going to find our two numbers. Now we have a system of equations. It's the best way to solve that system.
Substitution?
Now, when you got it in standard format, both equations, elimination's always the best way. So
Okay.
trust me. If you have two equations and one of them is already solved for one variable, then substitution is better. In other words, if my second equation said X was equal to Y plus 50, well, it's completely solved for X, so I would just go back into the first equation and substitute Y plus 50 for X. Then I would have one equation, one unknown, and I'd be on my way. But when neither equation is solved for a variable and both equations are in standard format, which is to say your X and your Y are on the left side and the numbers are on the right, notice what happens if I add these two equations. What do I get?
2x equals.
Notice the Y's go away. That's why it's called elimination, because we've eliminated one variable. Now I get 2x equals 160. X equals 80. We've solved for one number. What's Y got to be equal to if X equals 80? 30. So there's your two numbers. And I would have gotten those same two numbers even if I'd have made the second equation Y minus X equals 50. Would not have mattered.
Okay.
My Y would have come out to be 80 and my X would have come out to be 30. But the goal was to solve for both numbers. That's it. They didn't say, you know, which one is X and which one is Y. They don't care. Just which two numbers, add to 110 and subtract to 50. Well, these two. Okay? So that's as straightforward as they get. That's as simple as they get. Okay? Now,
Okay.
let's go back and talk about number 1 again.
Okay.
Well, they're talking about how far was it to the park. So let's make x equal the distance to the park. In other words, you can always define your variables based on the last sentence that they ask you, pretty much. In other words, whenever I come across a word problem, I go to the last part of the last sentence. That's where I start.
Okay.
Okay? Now, let's go back and see what equations we can come up with. I know that distance equals rate times time. Well, the distance to the park is the same as the distance from the park back to my house, right?
Yes.
So D doesn't change. So D, or what I choose to call X, is equal to the rate, 16 miles per hour, times the time it took to get to the park. So there's one equation.
Mm-hmm.
The other equation is the time that it takes to get from the park back to my house, where I slowed down a little bit. I was only going 12 miles per hour.
Is X?
X is the distance to the park.
Okay.
Okay? This was the equation I got by going to the park.
Mm-hmm.
And T is the time it took to go to the park, which they don't give us yet.
Yeah.
Okay? Well, when I go from the park back to my house, I'm going the same distance. It's still X, but I'm going at a different rate, and it's going to take a different time. So this is the time to get home.
Okay.
Okay? Now, notice that I still have 2 equations and 2 variables. I got X, which is what I'm trying to solve for, and I got the time it took to get to the park, and I got the time it took to get home. Well, that's actually 3 variables. I got X, I got T sub P, and I got T sub H. Well, I can't solve 3 variables and 2 equations. But I got another equation. What's my other equation? If the total trip took 7 hours.
TP plus TH equals 7.
There you go. Now we can solve. Okay. First of all, how do we solve this? This looks like 3 equations and 3 unknowns, and it actually is. But the one thing I know is that X is the same, right?
Yeah.
So the first thing I can do is set 16 T sub P equal to 12 T sub H.
Mm-hmm.
Now I can use this equation down here and substitute. In other words, T sub P is equal to 7 minus T sub H. So I'm going to substitute 16, and instead of writing T sub P, I'm going to write 7 minus T sub H. You see where I get that?
Yeah.
Now I've got 1 equation and 1 unknown.
Yeah.
I can always solve that. And once I solve for T sub H, then I can figure out what X is immediately. Well, let's do it. First of all, I got to distribute the 16. So I got 112 minus 16 T sub H equals 12 T sub H. What's the next step?
Divide, no wait. Add 16 to each.
Yeah, you want to get all your variables on the same side and all the things that don't have variables on the other. So I get 112 equals 28 T sub H. Divide both sides by 28. I get T sub H is 4 hours.
Okay.
Now, if I want to go and find the distance to the park, well, X equals 12 times T sub H. X equals 48 miles.
Okay.
Okay? These are a little tough, but I would expect nothing less. Are you going to Mullen also?
Yeah.
Okay. That's why I would expect nothing less.
Yeah.
They don't give you easy problems.
Yeah. I'll be going next year.
What's that? You'll be going there next year?
Yeah, I go to Dublin right now.
Oh, you do? Oh, okay. Well, that's just as tough.
Yeah.
What are you at Devlin? Are you a sophomore or a freshman?
I'm
A what?
8th grader.
8th grader?
Yeah.
Wow, good for you. You're taking honors algebra 2 in 8th grade.
I'm actually in Algebra 1.
Oh, this is honors algebra 1. Okay, well that makes more sense. I was going to say, what you're going to be taking calculus as a sophomore, but not if it's algebra 1. You'll take geometry next year, and then you'll
Yeah.
take algebra 2 as a sophomore, and then you'll take pre-calc trig as a junior, and then you'll take calculus as a senior. You want to be able to take calculus in high school if you have any kind of math skills at all.
Yeah.
So with this problem here, immediately I look at the last sentence. Find the rate of each train if the northbound train traveled 10 miles per hour faster than the southbound train. Well, let's start out with our variables. X is the rate of the northbound train, and Y is the speed or rate of the southbound train. Okay?
Okay.
Now, here's our picture. Here's the station. Okay? We got a northbound train heading that way at X miles per hour. We got the southbound train heading that way at Y miles per hour.
Mm-hmm.
But the southbound train doesn't start until 2 hours after the northbound train starts.
Yeah.
So let's see if we can come up with some equations. We know that at some point in time they are 360 miles apart.
Mm-hmm.
Okay? In fact, at 6 o'clock.
Yeah.
In other words, the northbound train left at noon. Southbound train left at 2 p.m. And at 6 o'clock, they're 360 miles apart.
Mm-hmm.
Well, let's see if we can come up with some equations. In other words, if we can turn this into two equations and two unknowns, x and y, then we'll be in good shape. Okay? Well, let's put some distances on here. We'll call that distance 1, and we'll call this distance 2.
Okay.
So let's talk about some equations. D1 plus D2 is equal to what?
360.
Okay. Now let's use our dirt, D equals rate times time, to figure out what the northbound train must be going. What is its rate? In other words, they're going at different speeds, but what's R sub 1? In other words, what's the rate of the northbound train just according to a formula?
It's R sub 2 plus 10.
Well, let's just take it one step at a time. In other words, d sub 1 is equal to the rate of the first train times the time that it's been traveling. And we'll call that t sub 1.
Mm-hmm.
And the distance of the second train is d sub 2, which is equal to the rate of the second train times the time that it's been traveling.
Yeah.
Well, I know that t sub 1 is 2 hours more than t sub 2, right?
Yeah.
So now I can say d sub 1 equals its rate times, instead of writing t sub 1, let's write t sub 2 plus 2, because it's been traveling for 2 hours longer than the other one.
Okay.
Bottom train, the one going southbound, the distance that it goes is it's equal to its rate times t sub 2.
Okay.
I also know that d sub 1 plus d sub 2 equals 360. So I'm going to add that plus that and let it be 360. So I get r sub 1 times t sub 2 plus 2 plus r sub 2 times t sub 2. That total distance is 360.
Okay.
Okay. Now, what else do we know? We know that r sub 1, the northbound train, is 10 miles per hour faster than the southbound train. So r sub 1 equals r sub 2 plus 10. Okay, let's go down and substitute that. In other words, we gradually want to eliminate our variables until we get to a point where we can solve it.
Okay.
So in place of r sub 1, I'm going to write r sub 2 plus 10. Still times t sub 2 plus 2 plus r sub 2, t sub 2. All of that's got to be equal to 360. And
Okay.
what do I know about t sub 1? Hold on a minute. These are the toughest when you have two trains leaving the station at different times. And I usually get lost about midway through this problem because I always end up with one equation and two variables. Notice that my last equation I've got has an r sub 2 and a t sub 2.
Mm-hmm. Yeah, it does.
Solve that all by itself. I need more information. Let's see. What have I used? I've used the fact that the time is 2 hours. T sub 2 is 2 hours later than T sub 1. I've used the fact that their total distance that they've both traveled is 360. I've used the fact that r sub 2 is 10 miles an hour less than r sub 1. And yet I still have two variables and one equation.
Well, isn't for the time it would be 6 hours for the northbound and
There you go.
4
There you
for
go.
that?
Yeah. T sub 2 is 4, right?
Yep.
Yeah, I know it's 4. Thank you. Very good. So now that I know what T sub 2 is, that's 4, because I know T sub 1 was 6. So I can substitute 4, and I get R sub 2 plus 10 times 4 plus R sub 2 times 4 equals 360. And that gives me 4R sub 2 plus 40 plus 4R sub 2 equals 360. That gives me 8R sub 2 equals 320. And it gives me the rate of the southbound train is 40 miles per hour, which means the rate of the northbound train is 10 miles an hour faster. There's your answers. Thanks.
Yeah.
And I usually get lost at about that same spot I got lost at. And thank you for filling in that unknown variable, which was not unknown. T sub 2 we actually knew. We knew that T sub 1 was 6 and that T sub 2 was 4. All right. Let's hope we don't have to do another problem like that. All right. 3 we did. The rest of these are usually pretty easy. Only ones that ever give people and myself trouble are those D equals RT problems where you got 2 different trains leaving a station at different times. Those are tough.
Yeah.
This one, not so much.
Okay.
There's 2 kinds of things that Nancy bought. She bought candy bars and she bought trail mixes. They want to know how many candy bars did she buy. Tell me what my variables should be.
Number of
X, you got to make up a variable. It doesn't have to be X. You can make up C for candy bars. But I like to use X and Y. Yeah, you can use any variable you want, but spell it out. It's the number of candy bars that she bought. And Y is going to be the number of trail mixes that she bought. Okay? Now, even though they only ask us to solve for X, we kind of have to assign a variable for trail mixes also, because we're going to come up with equations involving both candy and trail mixes.
Okay.
Okay? If a candy bar costs 50 cents and a trail mix costs 55 cents, what equation or what expression equals the amount spent on a candy bar?
Would it be X plus Y equals 20 dots?
Hold on, not X plus Y, because X is the number of candy bars, not the price.
Oh.
The amount you spend on candy bars is 50 cents times X, right? I mean, if you bought 10 candy bars, you'd spend $5 on candy bars. So this is a key realization right there, that the expression for the amount of candy bars is equal to the cost times the number that you bought.
Okay.
The expression for how much you spent on trail mixes is the cost of the trail mixes times the number of trail mixes you bought. And the total amount that you spent was $20.60. So that's how I get one equation.
Mm-hmm.
Now, the middle sentence says Nancy bought 5 more bags of trail mix than candy bars. What equation does that give me?
X plus 5 equals Y?
X equals Y plus 5. Now, it's easy to get this backwards like you did. Okay? Test it. If she bought 6 bags of trail mix, how many bars of candy did she buy? I got it backwards. Excuse me. You were absolutely correct.
Okay.
It's x plus 5 equals y, because if she bought 5 candy bars, she bought 10 bags of trail mix.
Yes.
And that satisfies that sentence. She bought 5 more bags of trail mix than candy bars. It really is easy, very easy to get this backwards, so it's always good that you do a test of it. Like I did. I made up a value for x, figured out what y was, make sure that it matches the meaning of that sentence. Okay? Now, I again have 2 equations, 2 unknowns, but this one is easier to solve by substitution because I have one equation that's fully solved for one of the variables, y. Okay, so I'm going to go into the first equation, and wherever I see y, I'm going to write x plus 5. So here's my new equation that I'm going to solve. 0.5x plus 0.55, and instead of writing y, I'm going to write x plus 5 using substitution, and that's equal to 20.6. That's one equation, one unknown. I'm actually going to solve for x, and that's all they want. I don't even need to solve for y, because all I need to do is solve for x. Do you have any problems? Do you have any problems solving that for x?
No.
No?
I don't think so.
Okay, good. Let's not spend our time doing that then.
Okay.
In other words, the secret on all of these problems is to define your variables and set up your equations. As long as I know that you know how to solve 2 equations and 2 variables, in other words, a system of equations, then we don't need to do arithmetic.
No.
Let's make sure you know how to set these up.
Yes.
Number 6. 2 dice. Are you familiar with dice?
Yes.
They each have one side, one number from 1 to 6. They have 6 sides. Each dice has 6 sides. And every side has a number from 1 to 6. So if I throw 2 of them, what's the chance that the sum of the 2 numbers that comes up is 1?
0, because there's 2.
Exactly. Exactly. What's the probability that the sum is 2?
1/6.
Well, that's the probability that one dice will come up on 1. But I also need the second dice to come up on 1, which is also 1/6. So since I need both of them to be on 1, I multiply the probabilities together and I get 1 over 36. That's the only way that 2 dice both come up on 1. And that's what you would need if their sum has to equal 2.
Okay.
Okay? So the problem as stated is pretty easy. But if I change it slightly, it's still pretty easy. You just have to know, well, what's the probability of getting a 1 on one dice and a 1 on the other, and both have to occur, so we're multiplying always.
Okay.
Okay? If both things have to occur, you multiply. What's the odds if I flip a coin that I would flip heads 3 times in a row?
1/8.
Good. Really good. Because it's 1/2 times 1/2 times 1/2.
Mm-hmm.
All right. Problem 7. Says it's a division problem, but in reality we know it's a multiplication problem, right?
Yeah.
All division problems of this nature, you're going to solve it by multiplying by the reciprocal. You're not going to do it as a division problem. You're going to do it as a multiplication problem. And we would always do that. So I'm going to multiply by n squared minus n minus 6, the denominator, and divide by the numerator. Now, the other thing to notice is that all four of these things are quadratics. And this always is going to involve factoring. Solution is always factoring. So start with the top left and factor it for me.
N plus 5 times n plus 2.
Bottom left.
N plus 2 times n plus 2.
And top right.
N minus 3 plus, no, n minus 3 times n plus 3.
N plus 2, is that what you said?
Oh, yeah.
And the bottom right. Difference of perfect squares.
I don't.
N minus 5, in other words, the square root of that minus the square root of that is always the first term, and the second term is just the conjugate of the first term. N plus 5. Okay?
Okay.
Now that we've factored everything, now we can cross off anything that's the same. In other words, I got an n plus 2 there, I got an n plus 2 there. I got an n plus 5 there, I got an n plus 5 there. I got an n plus 2 there, I got an n plus 2 there. And the only thing I'm left with is an n minus 3 in the numerator and an n minus 5 in the denominator. That's my answer.
Okay.
Okay? Now, before we go on, I want to point out one thing, because if anybody's going to get it, you're going to get this. In the problem we just did, I only canceled when the things were exactly the same, right?
Yep.
What is this equal to?
The same thing.
Minus 1. In other words, a minus b is always equal to the negative of b minus a. So 3 minus x is equal to the negative of x minus 3, which means that 3 minus x divided by x minus 3 is equal to negative 1. Okay? And this is really the only exception that I can think of, where you can still simplify that even though they're not the same. Okay? I certainly cannot simplify x plus 3 over x minus 3. I cannot do anything with that. Those are not the same, and one is not the negative of the other. Okay, so the only exception to the rule where you can only cancel the same things is when you have a situation where you have a minus b divided by b minus a. That's always negative 1.
Okay.
And if they give you a problem that's in, your numerator and your denominator, you got to simplify that to negative 1 or you won't get the answer right. So it is something that you might need to know. We didn't need to do it in number 7, but they could easily give you a harder one where you do end up with an a minus b over a b minus a.
Okay.
Okay. So now, number 8. Most people hate these kind of problems, but
I think they're pretty easy.
Yeah, there's just a method, and you just always want to use the same method. Now, I'm going to show you my method because a student taught me this method, and I like it better than the way I used to do it. What's the common denominator?
15.
I'm going to write it 3 times 5. The reason is is now what must my numerator be on the upper left?
X 3 times x plus 3.
How about if I write it like that? Is that the same number? In other words, the key is to make sure you do not change that fraction. Have I changed that fraction?
No.
No, the 5's cancel, and I can immediately see that I'm looking at x plus 3 over 3. That's why I prefer to write the denominator as 3 times 5 as opposed to 15. Because I can check to make sure that I've done it right, that I have not changed the fraction. Okay, what goes in the upper right of this numerator? Or what goes in this numerator, the second term?
3 times x minus 3.
Yeah, and these parentheses here are very important. And I know this is the same. The 3's cancel, and I would be left with x minus 3 over 5, which is what I started with. Okay? Now, I can solve it relatively easy. In other words, now I don't care. I'll go ahead and use 15, and I'll distribute the top. So the top becomes 5x plus 15 minus 3x. What's the next term?
Minus 3x minus 9.
Is it minus 9 or plus 9?
Plus 9.
Plus 9. In other words, the reason I put those parentheses in there is because this negative sign right there has to be distributed to all terms in that numerator.
Okay.
Okay? And if it was a plus sign, I wouldn't care. I wouldn't need the parentheses. But since it's a minus sign, I do need the parentheses. All of that's equal to 2, and now the problem is really easy. I can multiply both sides by 15, making that 30. Gather your like terms together, so you got 2x plus 24. I'm going to subtract 24 from both sides. I get x equal 3.
Okay.
There's your solution. But notice how cool that trick is, where I don't actually put the common denominator down there. I put it as a product of the two denominators. And the reason I do is because it's easier to check for mistakes. In other words, had I accidentally written that as 3 instead of 5, I would immediately know I've changed it. I no longer have x plus 3 over 3. I got x plus 3 over 5, so I know I've made a mistake. So your mistakes will pop out at you much faster if you use this technique. You write the denominator as the product. And it's particularly useful. It's particularly useful if you have variables. Say that's an x and this is an x plus 1. Well, now I'm writing the denominator as x times x plus 1. I'm not writing it as x squared plus x. Okay?
Okay.
All right.
My math teacher, he said like you could do like 15 times x plus 3 over 3.
You can do it that way. I used to always do it that way. It's just that I really think one of the secrets of math is to be checking along the way always. You don't want to finish a problem and then go back and check it. I mean, that's one way, but it's a lot harder. But if I check at each step, in other words, when I convert that fraction to a fraction that has my common denominator, I want to make sure I don't make a mistake in doing that. And by doing it, by writing that as the product of the two denominators, then I instantly know whether I've made a mistake before I even go to the next term. And that's helpful. If you can catch your mistakes along the way, you don't end up making as many. And you can always go backwards through a problem step by step that way. In other words, I know that I got the first step correct because I was checking it along the way. Now when I finish out the problem and I get an answer of x equals 6, or whatever it was, 3, now I can go back, and if that doesn't solve it, in other words, if I substitute my answer and it doesn't work, I don't have to go back and restart the whole problem from the beginning. I can go back to the last step where I know I was correct.
Okay.
Okay? A subtle thing, but thing that helps you not make mistakes is worth it. In other words, mistakes are the bane of mathematics. It's not so, you're very smart. I mean, you know more algebra than most of my Algebra 2 students do. Right now, you do. I'll tell you that right off the get-go. But even still, you're going to be subject to mistakes. And the key to getting perfect scores on your math test is check along the way.
Okay.
Now, number 9, how am I going to solve this? What am I looking at? What is that called?
I do not know.
Quadratic.
Number 9?
Quadratic with not only an x squared, but an x and a number. Well, whenever I find all of those in a quadratic, the way to solve it is to put everything on one side and 0 on the other.
Okay.
Because then by factoring it, in other words, if I put everything on one side, I get this, and that leaves 0 left over. Okay? Now I can solve this. In other words, I can't solve it as long as I've got a quadratic equal to 0. I have no idea how to solve that. But if I can factor the quadratic, and then I get 2 linear things multiplied together are equal to 0, well, I can solve that. I can solve it if I get it in terms of 2 linear factors, because the only way 2 things can multiply together to be equal to 0 is if one of them is equal to 0. That's the only possibilities. So now I set both of them equal to 0, so I get x minus 3 equals 0, which means x could be equal to 3, or x plus 1 equals 0, which means x could be equal to minus 1. So I end up with 2 solutions. And normally you need to go back and substitute both solutions and make sure they both work.
Okay.
Well, does 3 work? That would be 6 plus 3 equals 9. That's a true statement. Okay, so 3 works. Does minus 1 work? That would be minus 2 plus 3 equals minus 1 squared is 1, and that's 1. So minus 1 works. And the truth of the matter is that when you're dealing with polynomials, you rarely have extraneous solutions. So I'm not so concerned about going back and checking both my solutions on this problem. The kind of problems where you get extraneous solutions are where you have radical signs, where you have absolute value signs, or where you have logs, which you probably haven't even started yet.
Yeah, I don't know that.
But if you have any of these 3 things in an equation, then you're very likely that one of the solutions you come up with is not going to work, and you'll have to cross it out. You'll still have one solution, but one of them won't be a solution.
Yeah.
I don't know if you've dealt with any problems that have extraneous solutions or not. Probably not yet. Okay. It's the first step here.
Get one side to be 0.
Now, this is a quadratic, but it doesn't have an x term. So I don't need to put everything on one side and 0 on the other here. I could, actually quite solvable that way, but I want to do it a different way. Let's divide both sides by 64. And now, instead of solving it by factoring, I'm going to take the square root of both sides. Well, that gives me x on the right side. What's it give me on the left?
7/8.
Plus or minus the square root of 49 over 64, which is plus or minus 7/8. Now, this is a mistake that 95% of math students will make. They will leave off the plus or minus.
Okay.
And the only way that I can think of to get everybody to never make that mistake is to say that if you're ever solving an equation by taking the square root of both sides, begin your answer with the words plus or minus.
Sorry?
If you're ever solving an equation by taking the square root of both sides, begin your answer with the words plus or minus.
Okay.
Always. 100% of the time. Now, let's go back and see if I could have solved this by difference of perfect squares. Well, it turns out I could. In other words, if I subtract 49 from both sides, I get this. Well, notice what we're looking at. That is the difference of perfect squares, right? In other words, that's a perfect square. That's 8x squared. And that's a perfect square. That's 7 squared. And they're being subtracted. So it's the difference of perfect squares. And this always factors into what?
8x minus 7, 8x plus 7.
And notice that now when I solve it, I get x equals plus 7/8 and x equals minus 7/8. So when I do it this method, I don't even give myself a chance to make the mistake that is easily made doing it the other way.
Okay.
In other words, I automatically get the plus and the minus solutions. And you can always choose to do it this way, but very few people would. In other words, once you get this technique where you can take the square root of both sides, that's usually the technique that people like and choose. Just make sure you don't leave out the plus or minus.
Okay.
So if x squared equals 81, what's x equal to?
9.
No.
Plus or minus?
Plus or minus 9. Notice why minus 9 works. Minus 9 times minus 9 is 81. That's why it's plus or minus, because the negative works just as well as the positive does. Plus 9 times plus 9 is also 81. But if you leave off the plus or minus, you're going to lose points. You're going to lose credit on that problem because you left off half the answers. There's two answers. There's x equals 9 and there's x equals minus 9. So to get both answers, just always remember, in other words, in order to solve for x, I had to take the square root of both sides, right? Well, begin your answer with the words plus or minus, if that's what you're doing. All right, we don't have much time left. Let's do 12 instead of 11, where we have to graph it. Just we only have 2 minutes. And 12 I can do in 2 minutes. If f of x is the same as y, in case you haven't figured that out yet, they're interchangeable. I can write this as y equals the square root of 8 minus x, means exactly the same as f of x equals 8 minus x. The domain is the allowable values you can put in for x. Are there any values I cannot put in for x?
Why?
Could I put in 9?
No.
Because then I'd be taking the square root of a negative number, right?
Yeah, you can't.
So to figure out what values I can put in for x, I take whatever's in the radical and I say that it has to be greater than or equal to 0. Because I can take the square root of 0, and I can take the square root of positive numbers. I just can't take the square root of negative numbers.
Okay.
So when I solve this, I get 8 is greater than x, which means x has to be less than 8. So that, and if I want to turn that around, I can do it like this. So that's my domain. Have they taught you interval notation?
No.
Which would be negative infinity to 8. That's the allowable values I can use for x. In other words, I cannot use any value greater than 8. If I put in 9 or 10, I'm going to end up taking the square root of a negative number. I can't do that.
Okay.
Now, the range. Very last question we'll answer. What's the range? Meaning, what are the possible y values?
Greater than 8? No.
Y has to be greater than or equal to 0. Because when you take the square root of any number, it's positive. Unless it's the square root of 0. In other words, if x were exactly 8, which would be allowable, then I've got y equal to the square root of 0, which is 0. So y can be 0, but it cannot be negative. There's no way y can ever be negative, no matter what value I put in for x. So this tells me the range. The range is your allowable values for y. And in this case, they all have to be greater than or equal to 0.
Okay.
All right, Janessa, I will let you go. And
okay.
Let's see, we didn't quite get done. Is this your entire assignment?
It's a practice test for Friday.
Okay. Your mom mentioned that you may need another appointment if you don't finish this. I don't know that you need a full another appointment, but you might want a half-hour session or something between now and Friday to do these last two.
Yeah.
Actually, the last two are fairly easy. Simplifying that is just distributing the 4 root 2 to both terms.
Yeah, there's also a backside too. What's
that? Oh, there's a backside to this also?
Yeah.
Well, you might want another full session.
Yeah, okay.
Or Friday. And your mom knows how to schedule it on my website. At least I think she does. I think she did this one. Yeah. The blue means the student did it. Oh, she's already scheduled one for Thursday evening.
Yeah.
Okay. I will talk to you Thursday evening and we'll do the other side of this thing.
Okay, thank you.
All right, Janessa. Bye-bye.
Bye.